Hi, I'm Dr. Christopher Sutton. Welcome back to my Introduction to GIS video series. In this video, we will explore overlay operations. Overlay operations combine multiple data sets to reveal spatial relationships between the data sets. Overlay operations are spatial analysis techniques that integrate two or more spatial data sets, resulting in the creation of a new data set. Overlay operations are essential for analyzing relationships between different spatial features. In this video, we will examine common overlay operations. They will include intersection, union, clip, erase, and symmetrical difference. We'll begin with intersection. Intersection creates a new layer that retains only the overlapping areas of the input layers. It's based on the AND Boolean operator, which was discussed in an earlier video. Through intersection, we can extract portions of features from an input layer that overlap features in the overlay layer. Let's look at an example of intersection. Here we have two layers. On the left are watersheds found in central Illinois, and on the right are counties in central Illinois. They are to scale so you can see how the watershed areas are much larger than the counties. Here are the two layers georeferenced so you can see the location of the counties relative to the watershed areas. In the intersection operation, we are going to overlay these two layers. The output layer will contain only the areas that overlap each other. But within that space, the boundaries of both layers are kept, as well as the attributes of both layers. Here is the result of the intersection operation. To see this a little better, we will make this larger so you can see that we have several polygons which conform to the boundaries of watersheds and counties. So you can see an individual county is subdivided by multiple watersheds, or a watershed may be subdivided by several counties. The union operation combines all features from input layers. Unlike the intersection operation, union preserves all of the areas, including the ones that do not overlap. The union operation is based on the OR Boolean operator. The output layer contains all features from both layers. When we run the union tool, the output will contain the output extent of both layers, the boundaries of both layers, and the attributes of both layers. Where the layers overlapped, the counties and watersheds are intersected. But where the watersheds extend beyond the space occupied by the counties, we see the watersheds from the original layer. The clip overlay operation cuts out a portion of the input layer using the boundary or perimeter of another layer. Only the part of the data that falls within the boundary of the clipping layer is retained in the output layer. We will use the county layer as the clipping layer. We will end up with a layer that shows only the watersheds that fall within the area occupied by the counties. So the output will contain only the boundaries of the watershed layer and the attributes of the watershed layer. And here's the result of the clip function. Basically, all we are doing is keeping the watershed layer and removing any portions of that layer that fall outside of the county layers. As we zoom in, we will see only the watersheds. We do not see the county boundaries. The erase or difference operation is essentially the reverse of the clip operation. The erase operation removes parts of the input layer that overlap with another layer. It retains only the parts of the input layer that do not overlap with the erasing layer. What we will do is we will erase the space occupied by the counties from the watershed layers. The output will be the watersheds layer with the area occupied by the counties removed. The output layer will contain only the boundaries of the watersheds layer and the attributes of the watershed layer. The final common overlay operation that we will cover is symmetrical difference. Symmetrical difference identifies areas unique to each layer, excluding overlapping features. This is based on the XOR Boolean operator. You'll recall that the XOR Boolean operator results in true if we have features from one layer or the other layer, but not both. To see this, I will use an example that's different from our watersheds and counties. Say, for example, you're an urban planner in Chicago who wants to analyze changes in urban development between the years 2010 and 2020. The goal is to identify areas that were undeveloped in 2010 but urbanized by 2020, as well as areas that were developed in 2010 but reverted back to natural land by 2020. Here we can see the extent of urbanized land in 2010 shown in yellow. Here is the urban land in 2020. When we run the symmetrical difference, basically what we will see is any area that was urban in 2010 but not in 2020, or it was not urban in 2010 and then is urban in 2020. And here's the result of the symmetrical difference operation. The areas in magenta showed where we had change. Everything else did not change. In the videos that cover vector analysis, I covered only the common and basic operations that you would encounter. There are several advanced vector analysis techniques that I do not cover in these videos. This wraps up our set of videos introducing vector GIS analysis. Next, we will focus on raster GIS analysis.